Chapter 4 deals with quantitative data. So the thing we're going to start off with are what are the ways to display quantitative data graphically. There's four main types of graphs. So chapters 4 talk about histogram, dot plot, stem and leaf plot, and then chapter 5 mentions a box and whisker plot. So these are the types of graphs you can make for quantitative data. I'm pretty sure people have seen histograms before. Dot plots are essentially the same as histograms. A stem and leaf plot is a histogram that's been turned on its side. We'll talk about how to make those in class. Might make a video on that. And then again, box and whisker, I just wanted you to see another option. It doesn't come up till chapter 5. All right, a lot of the homework is going to say to describe the distribution. So we need to know what that means. So what should we do when a question says to describe the distribution? So for quantitative data, there are four things to mention. So an acronym to help people remember is SOX. So we have shape, outliers, or unusual features. C for center and another S for spread. We're going to see in chapter 5 that everything depends on the shape. But right now, just getting the acronym in our brain and what each letter stands for is going to be good. Okay, so one of those first things is the shape. So there's a bunch of different kinds of shapes. So here is one basic shape. So again, there's just a whole bunch of bars for like a histogram. You could also pretend there's a curve going around this if you're into curves rather than rectangles. Okay, so this has one peak right in here from way back in the day in elementary school. The number that shows up the most is the mode. So in this case, there's one main peak. So root word for one is uni, like unicycle, one-wheeled bicycle. But then it wouldn't be a bicycle. Good times. All right, so anyway, and if you drew like a line down the middle of this histogram, this half is roughly the same as this half, so they're mirror images of each other. So we've got roughly symmetric or symmetric and unimodal, which again is one peak, one number that happens the most. Okay, so here's another shape. What is this going to look like? So in this case, if you kind of, again, go towards the middle here, this half looks roughly the same as that half. So again, we've got a symmetric distribution. There seems to be a peak right here and then another peak right here. So when there's two peaks, the root word for two is bi. So we've got a symmetric curve or distribution, a distribution that's symmetric and bimodal. Whoa. Bothers me that that's there. I don't know what that is. Okay, here's another shape. So if you have something like this, this would maybe be if you roll the die, a number cube, like 1,000, let's say 6,000 times. You'd get about 1,000 ones and about 1,000 twos and about 1,000 threes and about 1,000 fours and so forth. So if the values the variable takes happens all about the same amount of times, if the frequencies are about the same, you've got a uniform distribution. And then I defined it underneath. So it doesn't have to be exactly like a flat top. It could be up and down a little bit, but so that again is uniform. All right, we've got a shape. So if something's not uniform, if something is not symmetric, it's got to be like lopsided. So here's the first one that's a little bit lopsided. So I'm going to show you actually both lopsided ones at a time. So if something's lopsided like that, they call it skewed. So we have two options for skewed. We could have maybe drastically skewed, like the bottom one. This is skewed, but maybe not as much as down here. If we went to the middle, like where half of the data is above and half the data is below, this top half does not look like that bottom half. And same over here. So this top half of the data does not look the same as that half, that bottom half. There's no like fold over in middle. There's no line of symmetry. So wherever the tail is, this tail is down here. This tail would be over there. I just didn't label it. The tail, the direction of the tail is the direction of the skew. So this top one where the tail is to the left, we would have skewed to the left. And this distribution down here where the tail is going to the right would be skewed to the right. So the direction of the tail is the direction of the skew. So those are those two distributions. So those are the, sorry, okay. There's the shapes. So one thing to talk about for describe the distribution is the shape. The next thing are outliers, so or unusual features. The unusual features are mostly if there's any peaks or gaps. Whoa, wow, good times. Okay, so an outlier is an unusual or extreme data value. It's either much higher or much lower when it's compared to the rest of the data in the distribution. When Chapter 5 comes along, we're going to have actual formulas to find outliers. So right now, it's enough to be able to look at a distribution of data and say, that looks like a strange data point. Let's label it an outlier. Okay, so after shape and outliers, we've got center. So how should I talk about the center of a distribution? And again, Chapter 4 is kind of like an introduction to Chapter 5 and quantitative data distributions. So in this case, center, you're trying to find one value that summarizes your entire distribution. So another way to think about it is, what's the typical value? So when you have your percentage in a class, like, oh, my typical score in AP Stats is an 85%. Woo! So these typical values in Chapter 5 are going to have two options for centers. So we'll specifically have the mean or median in Chapter 5. Right now in Chapter 4, we're just going to look at the distribution and go, the number towards the center or around the center or that looks about in the center is whatever. Okay, so then after the center, we have spread. This is the last one in our SOX acronym. So how should I talk about the spread of a distribution? And again, it'll be more numerical in Chapter 5. So in this case, we want to find a numerical value that tells us how tightly the values are clustered around the center or in relationship to the center. And I just wrote that the two options in Chapter 5 we're going to talk about for the spread or standard deviation or IQR. Most of us remember the range from elementary school, which is the maximum data value minus the minimum data value. That's not used so much in AP Stats. These are the two preferred methods for talking about the spread, just as an FYI. Okay, so with all of that said, let's actually maybe look at one. So in essence, this is pretty much all Chapter 4 is. We've got two distributions. In this case, there's two histograms. They aren't exactly drawn very well, but rough sketch, and it says to compare the distributions. So we could look at them individually, distribution 1 and talk about it, distribution 2 and talk about it, but for the AP test, they really want us to compare. So if we were going to compare these shapes, we could look back at all the list of shapes. We could go, well, this looks kind of like it's got a mirror image, a halfway point. If you folded this half over, it would look roughly the same. Same kind of thing here. It doesn't really have a long tail at all. So for this, I would say that both of these distributions are symmetric and unimodal, if you wanted to mention the unimodal part. Then for the outliers, it doesn't seem like there's really any strange, really unusual data points. I mean, maybe this is super far compared to the center, but it's not like there's a dot way over here somewhere. It's like, oh, wow, all the data is here, and then there's one value over here. Or, you know, maybe this seems extreme, Again, that's why chapter 5 is nice because it'll be a quantitative formula to decide if a value is an outlier. So right now I would say that neither one of these have any outliers. For the center, I mean, there's a peak right in here. So around 2025, there's a peak. And down here, the same kind of peak is happening. So both of these centers, I would say, are the same. So both of the distributions are symmetric and unimodal. Neither of the distributions have any outliers. The centers both seem to be around 25. The one main difference is that this top graph is a lot more spread out than this bottom graph. And if that's all you notice right now, that's fine. I tried to quantify it a little bit, just kind of eyeballing it. It's like, okay, well, most of the data is maybe, within 10 values from 25. Like you've got most of the data if you went 10 values away. Down here in distribution 2, I kind of went in the center, and if I say the center is 25, well, I mean, most of the data is less than 30 and like more than 15 or so. So I just said that this spread was maybe around 5, whereas this spread was maybe around 10. Again, that's just a complete guess. So that's me talking about them. If you would rather see it written down, here's my writing. So neither distribution has outliers. Distributions 1 and 2 are both symmetric with the center around 25. Distribution 1 is more spread out than distribution 2. Distribution 1, I said most values are within 10 units of the center, but in distribution 2, it's closer to about 5 units from the center. So I've described the distributions, their shape, outliers, any unusual features. We'll come back to that, especially in chapter 5. Their center and their spread. That brings us to pretty much all of chapter 4. The only other thing for chapter 4 is making sure we can make the different types of graphs, which we'll do in class.